Our boat Seize the Day is a result of a combination of pieces that will make it be able to transport the cargo. Let's talk about how it works. There are three main parts of the boat: the boat itself, that holds everything, the candle that heats up the engine, and the engine that helps move the boat. The buoyant force is what keeps our boat afloat. This is an upward force that is exerted on objects submerged in fluids. According to P equals P naught plus rho GH, if depth increases, then so does pressure. And if F equals PA, or force equals pressure times area, then the larger pressure means the larger force. So if the force exerted upward on the boat from the water is larger than the force exerted down on the water by the boat, then the boat stays afloat. Heat transfer is affected by temperature of the water cooling down the engine and the flame from the candle heating up the engine. The boat's thermal process looks like this. This is close to what an ideal engine would look like. From A to B, the flame from the candle starts to heat up the water inside of the engine, which causes the pressure to increase. The volume here stays the same, which shows there's no work done yet. Because there is no work, the first law of thermodynamics, internal energy equals heat added plus work, would just look like delta U equals Q, which means internal energy equals heat added. And if Q is positive, because we know heat is being added from the candle, then internal energy also has to be positive. This is also an isochoric process because volume is constant. Now, from B to C, the engine starts to expand, so V increases, which means there's a negative work done on the gas. Heat is still being added to the gas. There's a constant pressure and an increase in volume, which means temperature is increasing. If we use the ideal gas law, PV equals nRT, and we know that P, N, and R are all constants, and V increases, then T must increase too, which means temperature is increasing. Internal energy here is positive because the temperature increases and internal energy is proportional to the temperature, because U equals NK, which makes U proportional to K, or the internal energy proportional to the kinetic energy, and K equals 3/2 kBT, then K is proportional to the temperature. So that means internal energy is proportional to temperature. This is also an isobaric process because pressure is constant. Now from C to D, the water and steam start to leave the engine because the pressure outside is less than the pressure inside the engine. The pressure inside the engine was high because of the high temperature that it is at. Again, there is no change in volume, which means there is no work done. So internal energy just equals Q, or heat added. We know that heat is leaving the system because according to PV equals nRT, V, N, and R are constant. And P is decreasing, so that means T, or temperature, must also decrease, which means that heat must be removed. And if Q is negative, then so is internal energy because Q equals delta U. This is an isochoric process because volume is constant. And from D to A, W is positive on the gas because V decreases from cold water coming in and decreasing the temperature. We know temperature is decreasing because PV equals nRT, and if P, N, and R are constant and volume is decreasing, then temperature is too. So, which means that heat is being taken away. Again, internal energy is proportional to temperature, so if temperature decreases, so does internal energy. This is an isobaric process because pressure does not change. Why doesn't the boat go backwards in reaction to the water returning to the engine? Newton's third law states that for every action, there's an equal or opposite reaction. From C to D, the water jets backward out of the straws, which is the action, and the boat moves forward, which is the reaction. When the water comes back into the engine, the boat should move back as an opposite reaction, right? Well, the shape of the boat plays a big factor here. The front of the boat is a pointed shape. This makes it easier for the boat to cut through water with little resistance when moving forward, and then when it moves backwards, the boat has the flat back that causes more resistance, so it can't move back as much. And so, with more resistance when moving backwards and less resistance when moving forward, the boat will end up moving forward more than backwards. Seas of the Day, just like any other boat, needs a lot of physics to understand how it works.